Hey everybody, welcome back to The Will of the Maker. Now if you saw my last video on fuzzy skin, firstly, thank you. That video just absolutely blown up, and I think it really kind of helped a lot of people understand what fuzzy skin can actually do and what it's all about. It actually is a texturizing feature, which really is horrendously badly named. But in that video, a few people rightly commented that part of what I was doing was just masking, say, a bad printer or a printer that needs to be tuned or upgraded or whatever. And yeah, that is one of the benefits that fuzzy skin can do, is hide surface defects in a print. It's not the only thing, obviously. I think the main thing is the texture, but the hiding of, say, bad prints is a bonus. But I decided to deep dive of getting rid of the ghosting that the initial prints had systematically, so that I can know exactly what variable that I changed, how much of an effect it has, based off of a few different criteria I came up with. I designed my own test piece right here that will get into how I could systematically measure things and account for things and give different changes a rating system. So I went through several different variables. I have 16 different prints that I went through one by one to see really how much each change can affect the end result. And I even did one thing at the end that I haven't really seen people do before, and that actually made a really big change just by itself. So stay tuned for that, and let's get into getting rid of ghosting on 3D prints. Let's go. And just for reference, I'm using the exact same filament I used on the fuzzy skin video. I really wanted to get rid of it because it was possibly the worst filament I've ever used. So there is a lot of print defects still in here with inconsistent printing, and that is largely due to the fact that that filament is just awful. So forgive those, let's get into it.
Alright, so this is the test piece that I came up with. Both straight lines in X and Y. You can see labeled twice at different heights just to kind of give some more areas where you can read different things. There is a ruler along the top. This is in metric. It's 100 millimeters in either direction. The long lines on the ruler are 10 millimeter increments. On this main piece here, it is purely just walls, and then along the back it is wide enough to have infill. And we have basically 50 millimeters again in X, 50 millimeters again in Y, and then 50 millimeters in 45 degrees X and Y, just to see if there's any interesting interactions with it there. I also put in a little ghost there just for fun. And so that is the test piece I came up with. And let's get this loaded up in Cura and see what we can do. Okay, so here are the pieces in Cura. I used this as a baseline for a lot of different prints here. Basically anything that required a hardware change and not a software tuning change, I used this G-code developed here as a baseline so I can see how much the hardware change had an impact from the baseline. It is a 0.2 layer height, same line widths across the board. The wall thickness was set at 2 for everything. Baseline would be inside to outside wall ordering. Material was all printed in PLA. You can see the temperatures here, 220. That was the same throughout. Of course, print speed is an important factor. So as a baseline, I did 80 millimeters per second speed, which equates to a 40 millimeter outer wall speed, 80 interior wall. Of course, acceleration control, I set it at 1000 millimeters per second. I did try changing things for jerk as well, so I kept that at 20 for the baseline. And so this is basically what the G code looks like in the end, and we will print these out.
Alright, so the first print is done. This is what the baseline looks like without any tuning or anything, and without tightening the belts. So I'm gonna inspect this and then tighten the belts and reprint the exact same G-code and see how much tightening the belts makes a difference.
This is in Y here, which you can see in X there. A 45 degree, just to see how that looks. Look at it on the inside, how much rippling there is there. You can actually sort of see in the right light there, you can see where the infill is hitting the perimeters or the walls. And in order to get a good systematic approach, I came up with 4 different test criteria to look into. One being the length of the ghosting, how far does it go from this edge here down the side of the wall? And I try to measure that as consistently as possible. It gets worse in extreme lighting. You can see it for a lot further, but I try to be as consistent in my grading as possible. The next thing I tested were two different criteria for the frequency. One is the frequency of the first 3 waves. The first bit often has a higher frequency than other areas, so that's why I did that. The next would be how many waves are there in the first 20 millimeters of the print. And then the last measurement I did was the amplitude, basically how deep does the wave go. And I did that basically just by rubbing my nail on it to see where I no longer feel the ghosting effect. That's how I was able to judge it. And so from that, I decided to go forward and do a lot of testing.
And so here are the results for the first baseline test without any changes. You can see it looks pretty bad. The length of the ghosting in X is 45 millimeters and Y is 88 millimeters. You can see the period for the first 3 waves and the full 20 millimeter length is basically the same at about 1.8 millimeters per wave, and then the amplitude is pretty bad also. You feel it for the first 30 millimeters in X and first 60 millimeters in Y. And for the first attempt at improving this, I'm going to tighten up the belts on the printer.
Alright, so as a starting point, I'm going to put this all the way to one side, and you can easily see how loose these are. To tighten it, I'm going to loosen up one of these screws here.
And then basically just get some pliers and pull and twist on the belt to get it tight.
And the next is the Y carriage. Let's take this side off. Okay, so this is what this one looks like. These are super loose. It is a sort of similar story for adjusting these belts down here. Basically just need to loosen this guy up. And then scrap these guys. Well, that took a lot longer than I expected it. There wasn't a lot of extra belts for me to pull on the Y-axis. So I did what I could and I got it as tight as I could, but it might not have been much. So depending on how this goes, I think it's a little bit better. Maybe it'll be okay, otherwise I'll have to think of something else. So this is warming up, I'm gonna get it set up and then on to the next print. After tightening the belts a little bit,
Right off the bat, you can see a pretty good improvement in the length of the ghosting, especially in Y. It is less than half of what it used to be. So that's a pretty good change. And then also the amplitude of the waves changed significantly. The frequency for the first 3 waves got a little bit shorter, but after that was basically the same. Now I'm going to move on to individually changing different slicer settings, with the first one being the wall ordering, going from inside to outside to inside. This prints the outer wall first, and as the outer wall is printed at a slower speed, it should have a better effect on ghosting and not be affected by the interior lines, because a lot of times the inside wall can have an effect on the outer wall's appearance. So by changing the order of the walls, you might be able to get a difference. So let's test that out. And that actually made a pretty good difference. The change in length was almost as much as tightening the belts. In the case of X, it was even more. The amplitude was also reduced significantly, as were the frequency generally. After this, I decided to try out different motion characteristics to see how much of an impact they have. For testing different speed settings and acceleration settings and jerk settings, I basically did some modifiers within Cura. These are just basic support blocks that I grew in size to cover the whole part in X and Y. I did the first one at 10 millimeters height, then 5 and 5, and basically you can go through and change the speeds for each section.
So remember the baseline was at 80 and 40. So then to see how much of an impact of the speed would have, I did 3 more settings at 70 and 35 for inner and outer, 60 and 30, and 50 and 25.
Alright, so really quickly, whenever you see rows that are grayed, that means that those were hardware changes that cannot really be reversed. So any row in white is basically being compared to the first row above it that's grayed out. So for example, compare the speeds here to the row of tightened belts and not the outer skin first row. With that being said, you can see that speed clearly makes a pretty good difference. It is not surprising if you've been around 3D printing for a while. You know that printing slower typically means you get higher quality out of it, and this is definitely proven out here.
And then for accelerations, I did the same as for speed, 10, 5, and 5 for heights for these blocks. The baseline acceleration, just to repeat, was 1,000 millimeters per second squared. So for this one, I tested at 800, 600, and 400 millimeters per second squared to see the difference there.
And again, comparing to the tightened belts row, you can see that accelerations clearly made a pretty good improvement in most cases. The length of the ghosting was definitely improved, although not typically as much as speeds were. However, the improvement in the amplitude of ghosting was basically neck and neck with the changes that were seen with the difference in speeds.
And lastly, for the other print settings, I also changed the jerk values just to see how they would be. Baseline jerk values were at 20, but for this test, I went down in 3 millimeters per second increments to 17, 14, and 11.
I honestly didn't know what to expect with jerk. I'm not 100% sure of my understanding, but I believe what jerk typically is kind of like hitting the brakes before going into a sharp corner, and so you set a slow speed going into the corner to see how much that affects it. And for the most part, there was almost no change except for in the amplitude. Slowing it down did typically help improve the amplitude of the ghosting. And after that, I decided to rearrange my work area and built these shelves to put the 3D printers on. And these have MDF shelves, which should help absorb the vibrations. And this footage is from one of my shorts in case you didn't see it. And this change should be compared to the tightened belts change above. These have the exact same G code, only the difference in hardware changes, so we can see how much that shelf made an impact. And it generally did actually help the print quality overall. Having a different surface for the printers to rest on helps absorb the vibrations and improves the quality. You can see that there's a pretty big difference to both the length and the amplitude of the ghosting.
Hey, really quick break here. If you're enjoying this video, why not hit that subscribe button? I recently checked out my analytics, and of all the views I've been getting, only 0.5% are coming from subscribers. And so if we could get that percentage up a little bit more, I would greatly appreciate it. All right, now back to the video.
Another common change is to put your printer on some foam, typically some nice soft foam. I don't have any that would work, but I do have some old insulation foam, so I cut that up and put my printer on it. And honestly, the results basically showed that it made no difference at all, so it was pretty much a waste. The foam was probably too stiff and would only absorb any really high-pitched frequencies, which are not what's affecting here. I then did a quick run just out of curiosity to see with the printer on the MDF shelf and the insulation foam if changing the print order of the walls would change anything, and it did make an improvement like it did previously, printing the outer skin first, but not as much as it previously did. Okay, so one thing I did change kind of just on a whim was the flow. I changed it to 85%, just sort of thinking maybe that would have an effect. However, I later realized that there's another setting under speed called flow equalization ratio, where it uses speed or the flow rate to change a line width, and frankly I think I should have chosen this to change, but hindsight is 2020, as lowering this value does actually help improve ghosting by slowing the print head down. And overall, it did not have that much of an effect. The main change that it did have was to the amplitude of the ghosts, and I think that might largely be due to the fact that with less flow, there's less materials, so it doesn't stand out as much. One more thing I did test was alternate wall directions. This really wouldn't have an effect of the
ghosting itself, but I was thinking maybe if it's spread out in both directions, it's a bit of a optical illusion that it might be lower, because going into, say, coming into and out of a wall might balance each other out, and you might get ghosting on both sides, but maybe the effect would be less. So this is a little bit of a personal preference type of thing, but I decided to check it out anyways. And here are the results. In some regards, it is a little bit worse because the length is going in both directions, but it is also a little bit better in amplitude. Overall, I think that's just because of the ghosting going in different directions being more spread out. Again, this really becomes more of a personal preference type of thing. And then I decided to create some new TPU feet for my printer. So here are for the front and back, and also some for the sides, which are a little bit different design. And I sliced those up for some really old Ninja Flex, which is basically a TPU, and used gyroid because I thought that would be a nice little springy value for it, and see how that would have an effect on the printer. It's been a while since I've printed with this stuff.
3 days later.
I honestly had a lot of problems printing these, but in the end, despite being a stringy mess, they were okay. I did have to modify some of the ones on the side to fit around the main controller board, but in the end, I got the printer mounted on them. In the end, I was honestly a little bit disappointed with the results. I expected them to do a better job. Basically, the only improvement that they made was to the amplitude for both directions. The length actually got worse while having the printer on the TPU feet. I was always a little bit skeptical to the theory of dampening the whole printer and the base that it's mounted onto, and this kind of shows that maybe it doesn't do a whole lot because the printer is basically just one unit, and what we really need to dampen is the movement of the print bed or the print head around the parts. And so at this point, I took a look at all the different results that I found and basically saw what was the most impactful and kind of tried to combine the best of all worlds. So this basically included leaving the hardware changes, even though the TPU feet kind of hurt in length, but they did help in amplitude, so I left them. Obviously the MDF shelf is still there and the Titan belts. And then I made sure that the outer skin was printed first. I lowered the speeds to 50 and 25, the accelerations to 400. I also changed the jerk down to 11, and I set the flow to 85%. And I actually printed 2 different versions, and let's check them out. Final 2 pieces are done. Let's check them out. And here are the results for the first best of part. And comparing from the very beginning, you can see a significant improvement across the board. The only problem is this comes at the sacrifice of print time, going from 2 hours and 20 minutes to about 3 hours. But the quality does go up significantly. And the results for best of part number B show a similar story, maybe a little bit improvement. Now the difference is, I don't know. I meant to do alternating walls, but I cannot see any evidence of that. I tried looking at the G-code, both in text and visualized in Cura, and I can't see the difference. But there is a reduction in ghosting further from part A, and I just can't explain why, and I'm sorry about that. However, throughout this process, I couldn't help but think about there's got to be something else, and so I had an idea to basically try and dampen the motion system itself, not the entire printer, but just the print head. In engineering, everything is basically a spring mass damper system. It has a mass that's clear. Even if it's not a quote-unquote spring, it does have a spring value to it, some more than others. And then obviously there's a damper, because otherwise you'll have oscillations forever, so something eventually dampens it out. A lot of times, honestly, that's just air kind of helps to dampen things out. Think of it as the suspension of your car. You have a spring and you have a shock absorber. The shock absorber is the damper. If you did not have the shock absorber, you would just have a car constantly going like this. If you've ever seen like an old 80s car where the shocks are shot and the thing is just kind of going down the road like that, that's what's happening. It's lost its dampening effect. The shocks are shot. Some sort of dampening system is missing out of the motion system out of the 3D printer.
And I think that is a bit of a miss and maybe something that should be explored into.
And so this is basically what I came up with just to kind of test the theory. I took some of the cutoffs from the TPU feet that were left over and basically just cut them smaller and wedged them into the belt system. And while it is obviously having the effect of tightening the belt as well, but they are also dampening the vibrations, and you can hear that in the sound that they make. This is basically acting like a damper on a tennis racket, which does make a difference. And after printing it out, you can see the results here. All 5 different options here have the exact same G-code. The only differences are changes in hardware. And the percent differences are compared to the one above it. You can see just how much of a huge difference the dampened belt made over the previous one, and especially if you compare it to the baseline, how far you can get rid of ghosting just by changing some hardware tuning on your printer. And I think adding dampening to the belt system is a new opportunity to explore for the 3D printing community, as it shows a real big impact and what it can do. And if you want to compare the dampened belt to the parts that were printed with tuned G-code, you can see that the tuning and G-code really made no improvement compared to the dampened belts. But the tuned G-code comes at the cost of print time. So with the dampened belt, you are able to maintain the higher speed, but get improved quality at the same time. To me, that's a pretty significant finding. I hope you agree. And here you can see them next to each other with the baseline. You can see how far we've come from the baseline print, how far you can come in slicing and some hardware tuning, and then purely hardware with the dampened belts. And it's relevant to note that with the dampened belts, it was 21% faster print time than with the G-code tuning. And here are the results from all the different tests with the percentages comparing to the baseline, so you can see just where you can find the most difference in your prints. Anyways, I hope you enjoyed watching this video and learned something from it, and make sure you like, share, and subscribe. And if you don't want to do any of this stuff, you can always just add fuzzy skin.